Imagine finding a colossal flaw in the most meticulous astronomical record, a smudge that everyone ignored, only for it to reveal a whole other world lurking in the dark at the solar system's frozen edge. Nearly 6 billion kilometers from the sun, something was haunting the images of Pluto, a ghostly companion that would force us to rewrite the rules of our celestial neighborhood. The story of Charon, Pluto's giant shadow, is violent, frozen, and deeply, weirdly connected. Let's explore this together. Accidental discovery. How does one of the solar system's most significant discoveries happen? By seeing what everyone else throws away. The year was 1978, specifically June 22nd, when astronomer James Christie at the U.S. Naval Observatory was wrestling with photographs of Pluto. He noticed that while distant background stars were perfect points of light, Pluto was a smeared blob with a bulge. If the telescope or atmosphere were the issue, everything would be distorted, meaning the bulge had to be real. Christie hunted archives back to 1965, noticing the bulge systematically moved over time. He and his colleague Robert Harrington meticulously tracked the bulge, realizing it orbited Pluto every 6.4 days, perfectly matching Pluto's known rotation. This confirmed a massive, tidally locked companion. Christie named the moon Charon, a personal nod to his wife Charlene, whose nickname was Char. Inspired by his interest in physics, where particles often end in "on," he added the suffix. By an almost unbelievable coincidence, the name was a perfect mythological fit, as Charon was the spectral ferryman who carried souls across the river Acheron into the underworld ruled by the god Pluto. The name was officially adopted by the International Astronomical Union in 1986, cementing this accidental find as a cornerstone discovery and revealing a secret that had haunted our earliest images for years. The double planet. The discovery of Charon immediately began to unravel Pluto's mysteries. By tracking Charon's orbit, astronomers could finally apply Kepler's law to calculate the system's mass for the very first time, and the result was shocking. Bottom line, Pluto was incredibly lightweight, about 1/6 the mass of Earth's moon. Charon itself possesses a substantial 12% of Pluto's total mass, a ratio far greater than any other major moon in the solar system. Earth's moon is only about 1.2% of Earth's mass for comparison. This startling parity gives rise to a unique dynamic. Their center of mass, the barycenter, lies not inside Pluto, but in the empty space between them, approximately 960 kilometers above Pluto's surface. They perform a perpetual dance around this common, invisible point in space. Furthermore, they exhibit mutual tidal locking. Not only does Charon always show the same face to Pluto, but Pluto also always shows the same face to Charon, meaning the great moon hangs motionless in the sky from one hemisphere. These facts, the external barycenter and mutual tidal lock, led many scientists, like those debating in the early 2000s, to argue that the system should be reclassified as a double planet instead of a traditional moon system. This required a complete re-evaluation of the solar system's complexity. Kiss and capture. So, how did this strange, gravitationally bound duo form? For many years, the leading theory was a scaled-down version of our moon's birth, the giant impact hypothesis, where a massive Kuiper belt object slammed into proto-Pluto, creating an orbiting debris cloud that coalesced into Charon. However, as our understanding of rigid ice mechanics grew, this model showed cracks under extreme stress. More recent, sophisticated simulations, often run by researchers like those at the Southwest Research Institute, favor a different event, the kiss and capture theory. This proposes a much lower velocity grazing impact, less a shattering and more a cosmic kiss where the two proto-bodies temporarily stuck together, spinning as one before tidal forces pulled them apart, leaving them bound. This scenario explains how both worlds survived largely intact, aligning with observations showing Pluto is about 70% rock, while Charon is only about 55% rock, suggesting they did not thoroughly mix. Crucially, this story explains the system's heat, as the immense tidal friction during their separation deposited tremendous heat deep inside both worlds. This injected energy, was the starter pistol that melted the interior ice, firing off Charon's geological evolution as discussed by researchers following the mission data. New Horizons arrives. For 37 years after its discovery, Charon remained little more than a fuzzy, calculated companion. That changed fundamentally on July 14, 2015, when NASA's New Horizons spacecraft executed its fast flyby past the Pluto-Charon binary pair, transforming them from distant points of light into vibrant, complex worlds. The images New Horizons sent back from Charon were stunning, revealing a world that had, at some point in its distant past, torn itself apart through internal forces. The detailed mapping provided by the mission, overseen by mission leadership like Alan Stern, showed evidence of massive tectonic upheaval and geological dichotomy between the hemispheres. These new visuals provided the first tangible evidence of the interior thermal evolution driven by Charon's peculiar formation history. They allowed planetary scientists to finally map the surface in detail, revealing topography that told a story of expansion, not just external bombardment. The flyby proved that Charon was a dynamic world deserving of intense scientific study, not merely a satellite tag-along. Charon's surface. Charon's surface isn't smooth, it's dominated by vast tectonic faults, enormous ridges, towering cliffs and deep valleys that scar its face. The most spectacular feature is a great belt of chasms wrapping around the moon's equator, including the informally named Serenity Chasma. This system runs for at least 1,800 kilometers and plunges to depths of up to 7.5 kilometers, making it more than 4 times as long and nearly 5 times as deep as Earth's Grand Canyon. These are not canyons carved by water flow but colossal pull-apart faults, evidence that the entire crust was stretched to its breaking point. Scientists analyzing these features concluded that the immense heat from Charon's formation, plus radioactive decay in its rocky core, had melted the interior ice, creating a massive subsurface ocean. As that ocean gradually cooled over millions of years, water expands, pushing the brittle crust outward until it ruptured in these massive fissures, a process described by researchers like Kelsey Singer as a global-scale stretching event that permanently reshaped the world. The ocean world. The expansion from that internal freezing event is the primary driver of Charon's surface drama. Let me explain the physics. Unlike most materials, water expands when it turns to ice, as Charon's vast liquid water ocean beneath a frozen crust cooled over millions of years. This volume increase exerted relentless outward pressure on the shell above. The crust, unable to contain the force, literally tore itself open, forming the continent-spanning canyon systems visible now. This dramatic event confirms that for a significant time, Charon was indeed an ocean world, warmed by the kiss and capture impact and sustained by internal heat sources. While Charon appears inert today, the preserved fractures are a frozen snapshot of its ocean's death, a process essential for understanding the thermal history of small, icy bodies throughout the outer solar system. This internal heating, often cited by researchers like William McKinnon, was essential to this geological story. Cryovolcanic plains. The freezing of the ocean did more than just crack the surface. It actually resurfaced half the moon entirely, showing 2 dramatically different hemispheres. The northern region, called Oz Terra, remains the ancient, rugged and heavily cratered original crust, showing all the expansion fractures. In stark contrast, the southern region is Vulcan Planitia, which is a vast, smooth plain indicating a much younger surface, sitting at a lower elevation. Scientists believe this smooth region is a pretty extensive example of cryovolcanism, eruptions of icy slush, not molten rock. As the subsurface ocean froze, it pressurized the liquid water, which was likely mixed with ammonia antifreeze. This pressurized cryomagma was forced up through the new fissures, erupting onto the southern hemisphere and flooding the terrain like, well, icy lava. These features strongly support the idea that the expansion-driven fracturing provided pathways for the liquid interior to reach the surface in the south. a concept explored by planetary chemists such as Francis Nimmo in models of icy satellite interiors. Mortar macula. Perhaps the most visually striking feature on Charon is its north pole. Capping the top is a massive, dark, reddish-brown stain informally named Mordor macula after the Black Land from The Lord of the Rings. This color is almost certainly caused by tholins, which are complex organic molecules, a reddish, tar-like substance formed when simple compounds like methane are irradiated by the sun's ultraviolet light and cosmic rays. Tholins are pretty common in the outer solar system, but their concentration here is unique, requiring a persistent source of methane. The real mystery, as explored by mission scientists, is the methane source, leading to competing hypotheses. This is a visible chemical signature left by bombardment over eons, showing the long-term chemical activity occurring in this remote region. Researchers analyzed the spectral data gathered by the New Horizons instruments to better understand the chemical makeup of these complex surface compounds, a task that's vital to the surface geology team. Pluto's gift. The leading hypothesis explaining the red stain on Charon connects it directly back to its massive twin, Pluto. The scenario hinges on Pluto's thin atmosphere, rich in methane, slowly leaking into space, where Charon's gravity captures some of it. Consider Charon's extreme seasonal cycle. Its polar winter lasts over a century, with temperatures plunging below -240 degrees Celsius. At these extremes, the captured methane freezes directly onto the surface in a process known as cold trapping, a key mechanism proposed by atmospheric modelers like Willy Newman. When that pole finally rotates back into sunlight after a century of darkness, the accumulated methane ice is bombarded with UV radiation which cooks it into the reddish tholins we see staining Mordor macula. This paints a picture where Pluto is actively painting its companion across thousands of kilometers of space, a dynamic chemical exchange between the two worlds, suggesting a level of orbital interdependence rarely seen in the solar system. Interconnected worlds. Figuring out Charon's nature was a complex logic puzzle. The pieces were there, we just needed to decode them. It was hugely rewarding. Charon's orbit gave us the first true measure of Pluto's mass, reshaping our understanding of outer solar system bodies. It was Charon's existence that pointed to a shared, violent birth that sculpted both bodies and injected them with heat fueling their evolution. It's Charon's fractured surface that tells the clear story of a lost ocean, providing crucial context for understanding forces that may still churn deep inside the more active Pluto today. And its red pole may serve as a permanent record of Pluto's atmosphere, bleeding out into space over the eons, a testament to their bond. In mythology, Charon was inseparable from Pluto. Science has proven this true, revealing a unique binary system locked in an eternal dance, a fact powerfully summarized by mission scientists throughout the analysis phase. Charon's story started as a smudge James Christie almost missed, yet it reveals a world of deep canyons and ancient ice lava flows. You cannot tell Pluto's story without Charon. They are two halves of a single system bound by eternal gravity and a shared, violent past. This journey is a powerful reminder that our greatest cosmic truths often hide within the mistakes we are quick to discard. Even the farthest, quietest corners hold histories more dramatic than we imagine. If you were fascinated by this dual world, don't forget to like, subscribe, and hit the bell icon for more deep dives. Thank you for watching Sci and Why.